Hi everyone, it's Mrs. Sommer here to talk about the Unit 4 reaction rate review. So the Unit 4 test review. Your last test of the unit, or of the quarter. Yay! So remember, this test is going to be all short answer essay questions given in a Google Doc. So for lesson 101, it says, what three things have to happen in order for a reaction to occur according to collision theory? Well, the first thing that has to happen is a collision. A collision has to happen for a reaction to occur. They have to collide with the correct orientation or correct geometry. You could see it written either way. And they have to have enough energy to collide. The definition of activation energy is the amount of energy a reaction requires in order for the reaction to happen. Okay, and then this also asks us to sketch a reaction graph, and identify the activation energy required in the graph. So I bring it down here. So the activation energy is this. It's the distance between that top hump here and the reactant energy. So the distance between the top of the hump and the reaction starting energy. That is your activation energy. In lesson 402, we talked about the law of conservation of energy. So in these questions, it says, identify each graph as endothermic or exothermic, and how do you know? Then show if the energy is absorbed or released by the system. Finally, decide if the reaction will feel hot or cold to the touch, and explain what is happening for it to feel that way. So for this first graph here, if you notice that the product energy is lower than the starting reactant energy, it is an exothermic reaction. The product energy is below the reactant energy. And we know this versus the system versus the surroundings is that the system is releasing energy to the surroundings. So it's releasing the energy it has stored up here. And so the reactant energy or the product energy will be lower because we're also giving off energy in the form of heat. And does it feel cold or hot to the touch? Well, it feels hot to the touch. Remember, we are measuring it from the surroundings point of view. So because the surroundings is the system's releasing energy to the surroundings are going to feel hot to the touch. So this other graph here is an endothermic reaction. And I know this because the products are higher in energy than the reactants. And the system is absorbing energy from the surroundings. And because the system is absorbing energy from the surroundings, and we usually measure from the surroundings point of view, it feels cold to the touch. In lesson 403, factors that affect reaction rates, we talked about the 5 different factors that can speed up a reaction. So the questions here say, when answering a question below, make sure to reference the correct terms from the list. So you don't have to use all of the terms for each question, but you do need to use several of the terms in order to answer the question correctly and for full 4 points on the 4-point RRHS rubric scale. So the first question is, why do you think it's a bad idea to have a pressurized tank of oxygen near an open flame? Use what you know about factors that affect reaction rates to explain your answer. So if you think about it, the air that we breathe is about 21% oxygen. But when we compare it to a tank of oxygen, you can either buy those small tanks of oxygen for going up into the mountains, or people who are on oxygen daily because of reduced lung function, they have these tanks of oxygen. My son actually used oxygen when he first came home from the hospital for about a month. And we had this little tank to bring along anywhere we went. And then the reasoning is increasing pressure decreases the volume of the gas in the container, which means the more oxygen molecules in a smaller area. So think about the room that you're breathing air in right now versus a 2-liter container of oxygen. The oxygen is more compact, and so you're increasing the rate of any reaction with the oxygen molecules. So by reducing the volume and increasing that pressure, you're increasing the rate of any reaction in which the oxygen molecules might react. So oxygen is flammable. And when you have more oxygen molecules in a smaller space, you create a perfect condition for an explosion. So an oxygen-enriched environment is very good environment for fire. So fire needs oxygen to breathe, so to speak. So when you have a tank, and then you also introduce a second factor that increases reaction rate, so we increase the temperature, we're increasing the speed of the oxygen molecules now, and we introduce it to flame, because once you increase, if the oxygen molecules are moving too fast and for the container to hold, the container will then bust open or explode open, and now you have that flame with the oxygen, this new oxygen, and that flame will then expand exponentially because of all that excess oxygen. The second question is, why does sugar dissolve more quickly in hot tea than in cold tea? So again, when we increase the temperature of a water, it causes the water molecules to move faster, increasing the rate at which they come into contact with the sugar molecules, which increases the chances of a successful collision. Okay, you're increasing the chances of a collision happening. Then the next question is, how do you increase the surface area of an object? You increase the surface area of an object by breaking it into smaller pieces. So question 4 is, if a catalyst is added to a reaction, what happens and why? If you add a catalyst to the reaction speeds up because a catalyst lowers the activation energy for a reaction, which means it needs less energy for the reaction to start in the first place. And then the last question is, if I want a reaction rate to increase, what could I do to the concentration of the reactants? Well, to increase the rate of a reaction, I could increase the concentration of the reactants.